Great. Thank you and welcome everyone. So for today's presentation, just to review the quick agenda. So I'm going to start off with a few minutes just to level set everyone on what the relational database service is. And then we'll talk about planning your migration, some tools to help you migrate, and then a quick review of some recommendations before we get into our case live led by George from MarketLive. So the first point I wanted to cover is as you are considering moving your application to the cloud and Amazon Web Services, to just understand that Amazon Web Services offers many choices for managed databases. So today we'll be focusing on the relational database service for Oracle. We also offer our data warehouse known as Amazon Redshift, as well as a NoSQL database known as Amazon DynamoDB, and a caching service called Elasticache, which are not part of today's presentation, but oftentimes you like to mention that as you're considering a migration, to make sure you're selecting the proper engine for your application and not just moving what you're doing on premise today to the cloud, but making sure that your requirements are met by the engine itself. And so just as a quick recap, what is the Amazon Relational Database Service? Of course, it's a fully managed SQL database service. And today we'll be talking about RDS for Oracle, but we also offer SQL Server, MySQL, and Postgres. So as you're considering a place to land your application, we have a broad selection of relational databases to help you with that migration. And of course, the relational database service is simple to deploy and scale, and it's reliable and cost-effective. And a lot of the administration tasks that go into operating the relational database are handled by Amazon Web Services, which relieves the operational burden and allows you to focus on your application tuning and performance. And so just to provide a little bit of an overview, if we think about most on-premise databases today, we think about the entire stack of services it takes to actually maintain that database, all the way from power and cooling and server maintenance, operating systems, the databases, and scaling, as well as application optimization. Those are all under your control and fully responsible by your staff and team to manage. So the first choice that Amazon Web Services offer is by adopting our Elastic Compute Cloud and storage, you can essentially allow your database to run on the EC2 environment. And there are many use cases and customers that manage the database this way. Of course, under this scenario, you're still responsible, meaning your staff is still responsible for any kind of patching to the operating systems. And of course, all the database installation, patches, backups, and high availability. So it does provide a great flexibility in terms of moving your applications and databases to the cloud, but there's still a tremendous amount of work from a database administration that your staff would still be being in charge of. So the idea with the relational database service is, as you're considering your applications in the cloud, to allow Amazon Web Services to manage the database infrastructure, and of course allows you to just focus on the application optimization. And so things that are certainly critical to any database environment, such as patching, backups, recovery, high availability, these are all things that you inherit from the Amazon Web Services service and are relied upon as part of the partnership with Amazon Web Services, and allows your staff and your DBAs to focus on optimizing the application. So this is so that's kind of reviews our overview of the relational database service. Certainly if there's questions on some of the basics, we'll be happy in those other webinars that provide a more overview of the benefits of RDS for your applications. So let's just talk next a little bit about what a simple application architecture would look like. And granted, this is a simplistic view, just to have a few discussion points on. So of course, the first thing to think about is, where is your application going to physically reside? Most customers, as they're looking to adopt the relational database service, will install their application on the Elastic Compute Cloud, EC2. And of course, to take advantage of high availability for the application, they will leverage a multi-availability zone. So as a quick recap, Amazon Web Services operates in 10 different distinct regions. And each region consists of different availability zones. You can think of them as separate data centers within a region. And of course, having your application running in different availability zones will provide the high availability for your application. And then from the database perspective, RDS is you can configure RDS Oracle and our other engines to have a master database as well as a standby database in a separate availability zone. So any production instance, of course, we recommend multi-availability zones, so you can have a standby database configured and ready in case there is a problem in one data center or with underlying database components, and you can easily switch over to your standby to have that high availability environment, as well as your backups, which are automatically managed through the RDS service itself, and any snapshots of the database that you might choose to take will be stored in S3 for archival and recovery. And these are all topics that we have covered in different webinars that provide more details, and we're going to focus today a little bit more on the migration steps and not some of the underlying RDS value and service capabilities. So let's focus a little bit on migration planning. So again, specific to RDS Oracle, one of the first choices that comes in is which Oracle edition should I choose. So although the RDS service consists of 4 distinct relational databases, within Oracle, we offer 3 different editions. So of course, most customers are familiar with Enterprise Edition of the Oracle database. We also offer Standard Edition and Standard Edition 1. And under the Bring Your Own License model, any of your existing Oracle licenses will transfer to the AWS environment and to the RDS service. And so you can move, have a choice of EE, SE, or SE1, and migrate your licenses to operate in the AWS environment. There's a second option for Oracle Standard Edition 1, where you can actually take advantage of the AWS license included model. And what this refers to is your per hour charge that you see for RDS Oracle SE1 includes not only the compute and infrastructure in terms of the management that RDS offers, but it also includes the Oracle licensing costs for SE1. And so oftentimes customers will take advantage of this, for either they have a limited set of Oracle licenses to bring to AWS, or they want to provide more flexibility in terms of the hourly charge with SE1. And so that's a great option that we'll hear more about from George as he proceeds into the case study. So making that first selection, and oftentimes, if we are running Oracle EE on-premise, potentially, if you're not leveraging all of the EE features, there could be great cost savings and optimizations by choosing one of the other Oracle options based upon what your application requires and the needs of your SLAs, or service level agreements, back to your customers. So once we've chosen the proper edition of Oracle, the next thing to think about is just to review the user guide. So as a managed database service, obviously, there are some restrictions that we place upon things you could do or things that your DBAs might be most familiar with on-premise, because, of course, we are managing the backups, we're managing high availability, and so I would just encourage you to review the user guide, which lists out completely the features and capabilities of the RDS, and making sure that your application confines to those options within the RDS service itself. And there's a link that you can find back to the user guide that lists out specifically versions and capabilities that we support with the relational database service. And so once we've confirmed that is, then the next place I often talk to customers about reviewing for another documentation link is common tasks for the DBA. So this comes back to the fact that as a managed database service, there are certain roles in the Oracle database that we restrict, but there are oftentimes workarounds for different tasks. So please review the common tasks for the DBA, and I think that a lot of the questions that I get back in terms of how do I do certain features that I might be familiar with on-premise are frequently answered under this common tasks for the DBA section in our documentation. So the next thing is, once I've validated that my application meets all the capabilities of the relational database service, I will then make some instance selection options. So this essentially provides a wide range of instance classes for you to select from, and they differ based upon the compute, memory, and storage optimizations. And so there are a great number of choices that we offer under the relational database service, and of course you're always able to scale up or down, and so you will want to base your selection, of course, on performance, so the number of virtual CPUs, the ratio of CPUs to memory, and of course cost would be an important consideration as you're looking, because each instance will have a different cost, and it could vary by region as well. And remember that under Oracle licensing, There is a number of documentations available of exactly how your Oracle database licenses transfer to the cloud, and this is a policy set by Oracle itself. And then with the license included model, as I mentioned, your per hour charge would also include your Oracle licensing costs for Standard Edition 1. And importantly, as you're looking at your instance, I'll just recap again that you can scale up or down. So this is very simple to do. You just simply modify your database, choose a new instance class, and it will require a restart of the server itself. But once you've done some basic testing, you're not fixed in terms of the compute and memory that has been associated with a single instance class. You can easily go up or down based upon the needs, or as you see new instance types available by the relational database service. So next, I just want to review a few tools that are available. Depending upon where you're at in terms of the size of data, as well as the latency in terms of migration. So the simplest one that I'll start off with is SQL Developer, which again is an Oracle tool that provides a very simple way to migrate data. And this is most useful for very small data sets. So typically 1 gigabyte or less. So if you're just getting started with the relational database service and you want to move some sample data up, SQL Developer could be an option for you to quickly move data. And you can define, through SQL Developer, a source database, which could be on-premise, as well as a target database, which over a VPN connection into your RDS instance, you can simply load data, because even though it's a managed database from the AWS perspective, externally it's just presented as a regular Oracle database, which works with common tools like SQL Developer. The next option is SQL Loader. So this is a common tool that's used by Oracle DBAs to migrate data between instances. In this case, you can just take your SQL Loader text file and then copy it either into another Oracle database running an EC2 to then load into RDS, or load it directly into the RDS instance. And so SQL Loader could be an option if that's a tool set that your team is most familiar with. The next option I'll talk about is Oracle Data Pump. And so I do get, commonly a lot of questions around how Data Pump is used with RDS. And so this is, granted, a little bit of a simplistic diagram of how a Data Pump import would work. And I would, there is documentation in migrating to RDS for Oracle that goes through this in detail. But simply, take your Oracle Data Pump file. There's a number of tools and capabilities to move that file into an AWS environment. And from a relational database service perspective, we do expose a data pump directory that then you could load, physically place that file into and load it. Or you could use a helper database running an EC2 to be able to load that file in there. But oftentimes there's confusion in terms of the RDS service, but we do expose the data pump dir directory for you to both get data into RDS as well as get data out. And on the introduction slide, there is my email, gregkh@amazon.com. And if there's any questions on how to specifically use Data Pump, I'd be happy to answer them, which could be a separate 30-minute discussion in itself. The next option, which we recently added for Oracle, is Golden Gate. So if you do have your own Oracle Golden Gate licenses, you can leverage Golden Gate capability both from on-premise into RDS as well as between RDS instances. And you have a choice of where your Golden Gate Hub is actually deployed. So in this diagram, we're showing the Golden Gate Hub being deployed in EC2. You could also have that Golden Gate Hub deployed on-premise and then use RDS as a target. And this, of course, works between on-premise and RDS instances themselves. So if you want to operate in separate regions within AWS, oftentimes customers will use Golden Gate to move data between regions as well. And the great benefit here is that I might do my initial data load into RDS using a tool like Data Pump, but then to get any, to catch my database up to the current state, I could use Golden Gate as a mechanism to move transactions over once I've moved the majority of my data into RDS. There also is a number of partner solutions to be able to move data. So we talked about Golden Gate and some of the Oracle capabilities in terms of Data Pump. We do have a couple. This is not meant as an all-inclusive list, but I think these are 3 of the most common partner solutions that we work with. So The first is DB Visit. The second is Attunity. And the third choice, there's no link for this, but this is an open source project that does require a little bit more configuration on your part as a customer, but Tungsten Replicator is a great option for customers that are more comfortable with using open source projects to move data between your on-premise environment and the relational database service. So having gone through that, one last thing is the recommendations. So at a high level, I think these are, I think majority of the questions that often come to me around migrating into RDS Oracle. And so we did talk about data pump as an option. So sometimes customers might say, well, how can I move a 3 terabyte file or 2 terabyte file in terms of an export into EC2 or into RDS? And the first thing I would definitely recommend is to take advantage of the options that data pump has in terms of splitting files into a single export into multiple files, and then the parallelism that data pump imports offer as well. And just remember, as you're going from Enterprise Edition to lower editions of Oracle, that data pump does have some restrictions on those, but definitely take advantage of all the options that data pump has. And of course, we fully support those based upon the edition of the Oracle database in terms of the target. And then when you're physically doing your import of data, it's easy to select the largest instance of Oracle on RDS. And so this will provide more CPUs, more memory during the actual processing of the import, particularly if you're using something like data pump to do a bulk insert. And then once the import is completed, you can then choose the appropriate instance size for your production environment. And this will help shorten the time it takes to actually do the import, because of course you're applying more CPU, more memory. And of course, if you're using Enterprise Edition of Oracle Database in RDS, you could then take advantage of the parallelism that data pump on EE offers. And then the third recommendation is to, again, just for the import, choose single availability zone. So we talked about multi-availability zone being our recommendation for any production application. But what that encourages is, since I'm doing synchronous writes across 2 separate data centers to ensure that every transaction is written twice for my standby database, and I have a high availability configuration. But of course, for the import, I can choose single AZ, which will be more performant in terms of the bulk insert. And then once the inserts or the imports are completed, I can then enable multi-availability zone. Will bring your standby up to date with your primary, and then additional transactions beyond your initial load will, of course, be synchronously written across both those data centers. And the final recommendation is to look at provisioned IOPS. And so again, this webinar is not meant as a review of the different storage options, but we would definitely refer you to the documentation or other webinars that go through some tips for storage. But essentially, provisioned IOPS is a way to reserve a channel from your compute, which is your RDS instances, back to the EBS or Elastic Block Store, which of course is used for storage within RDS. And provisioned IOPS will guarantee a certain rate of IOPS. And this is not only great for production applications, but also because, of course, imports could be a peak time of IOPS back to storage. Having provisioned IOPS will give you better performance during that import operation. So having gone through some basic tips for the import, I'm going to turn it next over to George to go through their full experience of migrating an application from on-premise into Oracle Relational Database Service. So George, now the floor is yours.
Thanks a lot, Greg. Welcome, everybody. I wanted to talk, first of all, if you could take us right to the next slide, Greg. This is about how we adopted RDS Oracle's SE1 from a base where we were running with Oracle Enterprise. But before I dive into some of the technical details that we encountered and solved when we did that, I just wanted to give you a quick commercial for what MarketLive does. We're in the business of creating and customizing and hosting an e-commerce platform, a core piece of software that we deliver to our customers. And they use it to drive growth in both their online and their brick and mortar retail environments. You can see here sampling of the brands that we support, some that I think that you'll recognize right away. We provide all of the infrastructure needed to keep these sites up and running and selling the services and the goods that they sell on these sites, and the customers for the customers to use them for merchandising all of their retail offerings. And in total, we host about 120 sites for about 75 different customers. So all of this done now in a colo, and we're in the process right now of moving those sites into Amazon Web Services. The next slide, Greg. So our current configuration right now looks for most of our sites like the stack on the left, where we have a pretty classic network infrastructure layer, a web layer, an application layer with a couple of different services chunks in there, and a database layer. When we have a customer who has opted for a full disaster recovery environment, we ship the data, both the images and text and the code, as well as the database data via DataGuard off to an offline, off to a second location across the country. And that gives them a warm standby that we can bring that site up in the event of a loss of the complete data center. Of course, something that's never happened. The Oracle Enterprise clusters that we run in support of this are the core transactional engine there. They're running on Sun, Sparks machines, 5120s and 5220s, T4 and T3 clusters. As well as they run multiple instances on each cluster, Oracle instances, and multiple schemas supporting each one of those within each one of those instances. The merchant is isolated in the sense that each merchant has its own schema. And then the DataGuard standby features of Enterprise are used to do some offline reporting off of a standby database to set up this warm site standby when a customer's opted for that, and that supports the disaster recovery features that we offer to customers who have enough volume to justify the cost of that. The other features that we use out of Oracle Enterprise are online indexing. Of course, we're driving our OLTP performance for this to drive order taking for the customer and account management for individual end users. Many of our customers have millions of users that they track as they go through their sites. And it also serves as the catalog repository on the site. So in other words, all the products and SKUs that make up all of the site, as well as all the configurations for discounting and checkout details. Next slide, Greg. So as we began thinking about the move into Amazon Web Services, it required us to do some rethinking. That required some rethinking across the board. In some areas, we were able to move without making very many changes. And in fact, the application moved into AWS without making any code changes at all. But the deployment of Oracle was clearly going to be potentially a different way to go. So we had the enterprise features that we were using at that point. We had to go back through, and they had become just so much a part of our thinking about the way that we use Oracle that we needed to go back and enumerate everything that we were using that was clearly an enterprise service. And we took a look at what the alternatives were for using RDS and using Oracle in AWS, including the ones that Greg mentioned earlier, bringing our own licenses in there, using very large instances, or dedicating instances to each merchant. We took a look at and discovered some migration gaps for our ability to move databases into that SE. As you can imagine, with each merchant having its own schema and a couple of schemas to support their production environment, this migration process is going to be an individual piece as we move across. And then there's a learning curve for the DBAs, of course, as they're moving from enterprise into SE1 of how to operate in this environment. The deployment changes that we chose to make, primarily the first one was to use the license included model of SE1. And that was because we felt that that gave us the best cost and flexibility combination of all of the other options, and simplified our ability to or our needs to manage these Oracle instances, and especially the licensing world. I love talking to my Oracle rep, but not having to talk to my Oracle rep about licensing in AWS is a big attraction here into moving into this environment. The monitoring deployment was a change that we had to take into account, and we had to come up with a synchronization solution that I'll talk a little bit more about here. So let's go on to the next slide and talk about how we actually solved some of these problems. So on the Oracle Enterprise side, as we compare it to Standard Edition 1, some of the things that we found were that data guard replication was bringing us the ability to do these standbys for both reporting and for doing database, essentially warm standby backup disaster recovery. And in the SE1 environment, we can make copies of that data if we need to with RDS snapshots, and so we can make those available to our customers for example, for reporting basis. We also took on the Tunity replication tool, and that was valuable to us because it allowed us to connect directly from our enterprise databases in our colo running on the big clusters to these individual SE1 instances. Tunity has features that allow you to do this both on what they call DR environment, which is basically take the whole database, or what we use primarily, which is what they think of as their BI capability, which allows us to choose which of the tables and which of the system tables to move over. And that turned out to be more flexible and useful for us. And we use that today as we migrate customers into this environment to keep our colo database in production in exact sync with the RDS instance in AWS. And when it comes time for us to make the move, to move the site over, along with all the other work that we're doing with the rest of the application layers, it's a matter of shutting down new transactions coming into the colo version of Oracle, waiting for a minute or two for Tunity to finish the replication process and completely finish the synchronization, and then bringing the site up in the new environment. It goes that quickly. One of the things that I didn't note here as well is that that replaces data guard replication here as well, is that we did do as Greg suggested in our production environments, and we deployed multi-AZ on all of our production databases. And so that gave us some flexibility in terms of giving customers of MarketLive, when they move into this environment, the ability to run with 3 instances already up and running and ready to pick up in 3 different data centers at the moment any one of them has a problem. This gives us built-in disaster recovery for customers that goes above and beyond what we were offering coming out of the box for our customers. And we still are able to offer customers, and some of our customers are very interested in this and have opted for this, the ability to do a disaster recovery using the same Tunity software to replicate to a different region. So for example, we bring our sites up in US West 2, and we replicate for those customers interested into a hot site or one site DR environment in US East 1. And have those in sync so that we can bring those up there if we lose all 3 availability zones for any reason. Again, a very low probability event. One of the things that we have, of course, in Oracle Enterprise, and you would have in your bring your own license models here, is direct access to the OS. And if you use the license included, you lose that. And so that was a big deal for the DBAs, and this is something that they were very used to doing, scripting directly on the database server, running cron jobs there. And so what we adopted in this license included environment was a jump box approach, where we created an EC2 instance that is a location where we can connect into the RDS instance and operate there from that jump box. And so we've found that with some of the tools that Greg mentioned that allow us to drop data pump files into the RDS instance so that they can be picked up there. We've got that working. We've got a couple of different import and export approaches working there. We can run all of the monitoring cron jobs that we like from the jump box, accessing the RDS instance remotely. We haven't found anything that we can't do that way. And of course, there are some operations that we would normally be doing directly on the cluster machines on those instances that we now do through the RDS console operation. So for example, we've accidentally deleted a database while we were in development mode and then recovered that up to the minute with those RDS console tools. Very valuable. In fact, it was so good that the first time we did the recovery, we specified the minute after we had deleted the database, and so the first recovery failed because it took us all the way through to the point where we had deleted it, and it promptly deleted the database for us. And once we realized what we did, we just backed it up a couple of minutes and got exactly what we were looking for. Database migration across license types was an issue that we ran into. We didn't research this deeply because it looked like the Attunity system was able to help us move data seamlessly from enterprise to the SE1, whereas we were starting to get some errors about not being able to take directly the data pump files from enterprise into an SE1 instance. There are probably some other ways to go after this, but Attunity completely eliminated that issue for us, that we didn't have to deal with that at all. And the one thing that we haven't found a remedy for here is online indexing. In Standard Edition, you have to do maintenance to put new indexes up. We're still looking for ways to go after that. And that is something that right now we are just making the plans. We don't do this very often. Occasionally we'll want to add a new index, and we'll just end up doing that in a late night maintenance to go after those kinds of tasks. Next slide, Greg, please. Thank you. So the DBA Learning Curve was an important piece of making this work, and we took our time to get through this. We spent about 9 months going through the process of doing experiments and working through the details here. Some of the things that we worked through here, it was just getting over the fact of not being able to log into the RDS instance itself. As you can imagine, that was a big deal. And there were lots of days when we were talking about, well, we can't do this and we can't do that, and eventually we figured out ways to make all of those things work. The workaround I mentioned for the data pump exports and imports here, that was a challenge at first, but we got the AWS way working. I said we're still learning it. We actually got this working for ourselves in the last couple of days. And in the meantime, we've been using straight imports and exports successfully. We, of course, had to make some changes in the naming conventions, because when you're in a single cluster, you name things differently than you would if you're going to be in an instance that's dedicated to an individual customer. That's changing some of our operations practices, and that's also changing the way that we're thinking about managing a single large cluster versus many merchant individual deployments. We expect to use more extensively our Puppet implementation in this environment, so that things that we would normally do manually in these environments are going to be things that will end up where we want to make changes to multiple customers. We'll be able to push those out with a Puppet task. We are re-implementing a few of our monitoring scripts, but the majority of them turn out that we can take them directly into that environment. We just have to go through a normal testing process, and that is a part of our normal database management practices here at MarketLive. We did have to refactor one issue, and that was the one piece of code, and that was post Enterprise allows you to run a post stored procedure script in the operating system, and that's something that is not part of the capabilities in the RDS environment with Standard Edition. And so what we've done is just basically build a small messaging table where we list the tasks that we need to do, and then from the jump box we're running a process that checks that, pulls that table, and runs those. So for example, in some cases, we'll want to restart JVMs after we get done with a particular stored procedure on the production environment, and they drop that off, and we end up running, once the stored procedure is done, it drops something into that table, and that monitoring script on the jump box is grabbing that task, executing the JVM restarts, and that brings all the new changes in the database up and live in the production environment. And then finally, as I mentioned, maintenance is required for doing the new index creation on the large tables. In some cases, we were having to do that in our clusters anyway on the very large tables, but as I said, this is a relatively rare event and one that we don't have to spend a lot of time on. Next slide, Greg. So I think the last thing I wanted to talk about was just the lessons learned that we took out of this experience so far. I think we're going to be continuing to learn as we go here. And especially we're very excited about taking our first sites in through our first retail peak through Cyber Monday and Black Friday this year. The first thing is take advantage of the AWS RDS team. It's a great group. Very open and willing to give us time to work through issues and to answer questions, very patient with us. And we made extensive use of that team through our account rep and with well-focused meetings with agendas of a list of questions that we wanted to get answered, and to, more important than just answering questions, have a dialogue about the best ways to take advantage of the environment and to solve problems that we were running into. The DBAs on your team need to have time to get familiar with the changes that are going to take place as they move from enterprise and downshift into standard edition. But one of the things that we as a team said that we weren't going to accept that there was a task that can't be done. We knew that there had to be a way to get all of these things handled one way or another, and that was something that held us in good stead as we went through this project. It was an important attitude to have taking into the process. And then along with that, definitely encourage you. We dug into the features and functions of the RDS console over time. Definitely recommend that you get into that early and often. Go back and review it. Things that you didn't make sense to you immediately makes a lot more sense, and once you start running instances there. And so, and of course, having a test environment where you can practice with those so that you know what to expect in terms of things like how long does it take to add disk when you are short on disk on an instance, how does a configuration change go in and there, taking a chance to getting yourself a chance to see what it's like to take a database down in a multi-AZ environment and see how it picks up in the other AZs. All of those things are important things to get a feel for in a test environment and make sure that you've got that working there. And Amazon's capabilities in being able to provision things quickly in those environments make it easy for you to set up those test environments. And then finally, we recommend highly, and I recommend the RDS Business Support. Great response time on the team and excellent expertise online. When we get into a tough spot, they're there right away. We can get on the chat with them, on the phone with them. We can do email support for less critical time-critical issues. But overall, very pleased with the kind of support that we were getting. We recommend that if you're running in production, you got to have production-level support from this team, and they know how to do that.